Yes, sir.
Eigens principle, correct? Eigen principle what? Number one, okay, light, okay, from source travels in all directions, okay, in a medium. The locus of all the particles, in the medium which are in same phase is called wavefront. What he's saying, first we'll explain this, we will finish. Okay? Every point on wavefront, every pointer wavefront behaves as source for the next wavefront. Every point on wavefront behaves as secondary source for the next wavefront and travels in forward direction only. This I'll explain, okay? First you copy this, I'll explain now with the figure how it's coming. Okay. I'll explain here. See, let us consider a point source. From the point source, light travels in all the directions. It travels in all the directions with the same speed. Okay? Then after some time, the distance traveled by light is c into t. After ct, it will be here. It travels with the velocity c. In a time t, what is the distance traveled by light wave? ct. It will come from here to here. Similarly, here to here. Similarly, here to here. Similarly, here to here. Similarly, here to here. Like this. Like this, like this. So after t seconds, it will reach to the same point like this. Okay? And these particles in the medium, they are in the same phase. Means this part, that is light when reaches here, this particle starts vibrating. Similarly, this also starts vibrating. This starts vibrating. These all particles start vibrating. Locus of all the particles which are in same phase. Locus of all the particles which are in the same phase. So these all the particles are in the same phase. Okay? The locus of all the particles which are in the same phase. This is called wavefront. This is called wavefront. Followed? Which are in same phase is called wavefront. So this is wavefront. And next sentence, what is given? Every point on this wavefront, behaves as secondary source for next wavefront. When this is a point. Around this point, now this behaves like a point source. Around this, like this. Around this, like this. Around this, like this. Like this. Around this, like this. Okay, this is a point source. Like this. So every point on the wavefront behaves as secondary source for the next wavefront. Next wavefront. Next wavefront, like this. Okay. And again, these wavefront, the part of the wavefront, this is called what your forward wavelet. This is called backward wavelet. Backward. This is a forward wavelet. This is a backward wavelet. Forward and backward. Forward and backward. Wavelet is a part of the wavefront. Now this is the wavefront, no? The part of the wavefront is called wavelet. So this is called forward wavelet. This is called backward wavelet. Follow? So like that. And again, the locus of all these, okay, the locus of all these wavelets, all the wavelets which are in same phase, this is another wavefront. This is called what here? Another wavefront. Okay, and this is another wavefront. This is the first wavefront. This is the secondary wavefront. Because the secondary wavefront derived from this secondary source. And he told that the part of this wavefront, this wavelet, cannot travel in what direction? Backward. See, behaves as secondary source for the next wavefront, travels in forward direction, no backward direction, no backward direction. अंदर वही दिलीप को तो दिलीप को ही no backward direction, only forward direction, right? Like this. Okay. Now, any straight line drawn perpendicular to the wavefront, any wavefront drawn perpendicular to the wavefront is called ray. Psi. So, any straight line drawn, this is a wavefront, no? For this wavefront, this line is how it is? Perpendicular. So, any straight line drawn perpendicular to wavefront is ray. R-A-Y, ray. Okay? These are called rays. These are called rays.
Sir? What are those small circles called, sir?
These circles are called wavefronts. These are the wavefronts. This is the big wavefront. This is the wavefront. These are the small wavefronts derived from secondary source, because this is the original wavefront, no?
Yes, sir.
But on the original wavefront, every point behaves as a secondary source for next wavefront. जैसा आप एक source लेके wavefront ऐसा बनाया, similarly you take, this is a point source. Around this point source, you take again another wavefront, you draw it.
Yes, sir.
This is a point source, you draw a wavefront. Point source, you draw a wavefront. Point source, draw a wavefront. Like that. And he is insisting that these wavefronts travels only in forward, not in backward. Means these wavelength, this part of the wavefront, this is a wavefront, no? The backward wavefront called wavelet, forward wavelet. Part of the wavefront is called wavelet. No backward movement of wavelet is telling. Only forward movement, like this only.
Okay.
Sir, what do you exactly mean by locus?
What is exactly mean by
Locus.
locus? Locus means path. It is a mathematical word. Locus means path. Locus of, see, light, यहाँ से निकला ना, the light which is started from here, that light is traveling this direction, this direction, this direction. In all the direction, light is traveling. Okay? But the light, by the moment this light reaches from here to here, the light here reaches from here to here, here to here, here to here. So after t seconds, the light particles reaches here, here, here. So now in the medium, in this is all medium, no? In this medium, when light reaches here, this particle starts vibrating SHM. When light reaches here, this particle starts vibrating SHM. When light reaches here, this particle starts. So these all the particles at the same time light reaches. Light reaches, these all the particles at the same time. So this all the particles starts vibrating at the same time SHM. So these particles are in the same phase because they starts vibrating simultaneously. So this, the locus means Locus means path. The path joining all the particles which are in the same phase is called wavefront. Locus means path. Okay, na?
Yes, sir.
ఇది ఒకటి కప్పు పెట్టుకో నువ్వు దాంట్లో రాను ఎవరు కప్పు వాడదు తాగి ఒప్పుకోరు కరోనా టైం కదా రోజు వాడదు రెడీ పెట్టాలి క్లాస్ నడుస్తుంది క్లాస్ నడుస్తుంది వాళ్ళ అమ్మ పైసలు ఇస్తారు కాబట్టి అమ్మ మంచిది పైసలు ఇస్తారు ఎవరు పైసలు ఇస్తే వాళ్ళు మంచిది వదలదు Okay. Next, shape of wavefront. Shape of wavefront depends on type of source. Okay. So this is a point source. What is the shape of this wavefront? Sphere, correct? So for point source, wavefront is how? Spherical. For line source. అప్పుడు ఉడ్చుడు అయిందా ఉడ్చేసి అన్ని అయిపోయా ఫర్ లైన్ సోర్స్ cylindrical wavefront. How? This is the line source. Line source means it is a straight line. These are all the points. Source, no? So light travels in all the direction like this. So what is the shape of this wavefront? Like this. Tube light. Cylinder. So that is the wavefront. Shape of the wavefront is cylindrical when the source is line source. Okay? రే సాయి పొద్దున్న లేవని కాలేజీ నడుస్తుంది ఇక్కడ పేపర్ చదువుకో పేపర్ వచ్చింది కదా న్యూస్ చదువు సినిమా లేదు సినిమా తప్ప వేరే లేదా See. Now, what are the rays? This is the wavefront. These are called rays. What is a rays? Rays are straight line drawn perpendicular to the wavefront. These are all the rays. Okay, next for extended source. For extended source, wavefront is what is a wavefront? Wavefront is planar. Etla. Extended source means source which is at infinity. So for extended source, these are the rays coming from extended source. And what is the nature of wavefront? Planar wavefront. Like this. This is a wavefront. So for extended source means source is at infinity. So what are the rays? This is the wavefront. Any straight line drawn perpendicular to wavefront is ray. How the rays are for extended source? Parallel beam. This is a parallel beam. Your source is at infinity. Right?
Done, sir.
Okay. Explanation of Snell's law. Snell's law of refraction using Eigens wave theory. Now we are going to explain Snell's law of refraction. You know, sin A by sin R equal to mu, correct? So that Snell's law of refraction we are explaining using what? Eigens wave theory. Okay? See, the Rabjala, top D.
Yes, sir.
Yes.
Now we are explaining refraction using Eigens wave theory. Listen. Now, suppose this is a medium 1. This is medium 2. Okay? Now its refractive index is mu1. This is mu2. Okay? Suppose a parallel beam. What is meant by parallel beam?
Sources at infinity.
Source is at infinity. Now this parallel beam is incident like this. Parallel beam means what is the nature of the wavefront?
Planar.
Planar wavefront. See, this is a planar wavefront AB. So this is the wavefront. This is the parallel beam. This is a point C, right? Now a parallel beam of light or a planar wavefront incident on a medium 2, right? Coming from medium 1. So now you draw a line which is perpendicular to the medium. Any straight line drawn perpendicular to medium is called
Normal.
normal. And ray perpendicular to wavefront is called, these are rays. These are the rays. Because this is the wavefront. All the particles on the wavefront are in same phase. Correct? All the particles on this wavefront, they are in the same phase. Okay. Now the problem starts. Light particle, which is at B, is coming from B to C. These are all the particles are in the same phase on this AB wavefront. So this is the particle which is already at point A. This is particle at B. By the time light particle reaches from B to C, the particle which is already at A, it has to enter into this medium 2. Medium 2. Correct. So this light is traveling from point B to the point C with what velocity? V1. It travels with V1 velocity. Right? So, now what is the distance traveled from here to B to C? BC is how much? V1 into T. Here, the particles on AB wavefront are in same phase, correct? Are in same phase. By the time light reaches, light particle, light reaches from B to C with velocity V1. So BC equal to V1T. So in what time the light reaches from B to C? T seconds. So BC equal to V1 into T. Okay. Reaches from B to C. But by the time it reaches from B to C in T seconds, but already particle at A, it has to enter into the medium 2. With the velocity V, the particle or the light from A, light from A enters into what? Into
Medium
2. Medium 2. With velocity V2, correct? Not same velocity, no?
Yes.
V2. So, now this is rarer. This is what? Denser. So, V2 less than V1. Why? Medium 2 is
Denser.
denser.
So the light from A enters into medium 2 with the velocity V2. Okay? Travels how much? V2t in same time. What is the time taken by the light reaches from B to C? T seconds. Kada? In the same time, T seconds, what is the distance traveled by the light particle from A